Okay, so for those of you who are absent, we have a challenging right triangle trig problem. A boat is traveling due north 1,000 feet from and parallel to a shoreline that also runs north-south. An observer from a lighthouse on the shore notices that the bearing from the lighthouse to the boat changes from 145 degrees to 130 degrees during the period of observation. How far has the boat traveled during that time? Okay, so let's start with the north-south line. Helps us draw the bearing, and the boat is traveling due north as well. So we have a shoreline running north-south, an observer from a lighthouse on the shore. So let's put our observer here. We'll call this our lighthouse. And they notice a boat. So from 145 degrees, let's put that quite a bit down. Let's say that's approximately 145 degrees. To 130 degrees, looking at these bearings, so a slightly shallower angle for the 130 degrees. And then we have the boat going north-south as well, or it's traveling north. So we see our boat is traveling this distance, it's going north. We want to know what that distance is, but the thing is we want to use right triangles for this. So let's extend this line. And then we can see that to make a right triangle, we have to make a straight line through here. And then what it produces is two useful right triangles for us. So let's fill in the information at this point. So in this smaller right triangle, it was the 130 degree bearing. 90 degrees are outside the triangle, which means we have 40 degrees inside the triangle. This larger triangle, we had 145 degrees outside the triangle, which means we're left with 55 degrees inside the triangle. On the smaller triangle on this side, we had 45 degrees in one corner, which leaves us with 50 degrees in the other corner. Again, we had 55 degrees in the large triangle in one corner, which leaves us with 35 degrees in the other corner. So let's take a look at the information we know. The boat is 1,000 feet from the shoreline. So that means this distance here is 1,000 feet. We have x is what we're trying to find. To finish up our right triangle, we also need to use this distance here, which I'll label as y. Okay, so let's set up some trig equations. You can use tangent or cotangent. It's your choice. For right now, let's use tangent. So I have tangent of 40 degrees excuse me, is equal to y over 1,000. I have tangent of 55 degrees is equal to x plus y over 1,000. And again, eventually we want to solve for x here. So let's take a look. I've got 1,000 tangent of 40 is equal to y. And I'm going to solve the other equation for y as well, so that I can set the two equations equal to one another. So that gives me 1,000 tangent of 50 is equal to x plus y. 1,000 tangent of, that's a 55, minus x is equal to y. So we have then 1,000 tangent of 40 equals 1,000 tangent of 55 minus x. And how nicely our x has ended up as the only variable in this equation. So let's take a look. I have 1,000 tangent of 40 minus 1,000 tangent of 55 is equal to, negative x. That means x is equal to 1,000 tangent of 55 minus 1,000 tangent of 40. And when we evaluate that, we should get x to be approximately 589.0 feet.